Hello viewers, welcome to the section Standard Template Library. In this section, we will learn about the Standard Template Library architecture, functors and sequence containers, array, vector, list, Forde list, and dequeue. Now we move on to the video, the Standard Template Library architecture. In this video, we will learn about STL algorithms and iterators. The C++ Standard Template Library offers ready-made generic containers, algorithms that can be applied to the containers, and iterators to navigate the containers. The STL is implemented with C++ templates, and templates allow generic programming in C++. The STL encourages a C++ developer to focus on the task at hand by freeing up the developer from writing low-level data structures and algorithms. The STL is a time-tested library that allows rapid application development. To get better performance, the STL avoids dynamic polymorphism, saying goodbye to virtual functions. Broadly, the STL has four components: algorithms, functors, iterators, containers. Let's understand the major components of STL one by one to get a good grasp of the STL conceptually. First, we will learn about algorithms. The STL algorithms are powered by C++ templates. Hence, the same algorithms work irrespective of what data type it deals with or independently of how the data is organized by a container. Interestingly, the STL algorithms are generic enough to support built-in and user-defined data types using templates. As a matter of fact, the algorithms interact with the containers via iterators. Hence, what matters to the algorithms is the iterator supported by the container. Having said that, the performance of an algorithm depends on the underlying data structure used within a container. Hence, certain algorithms work only on selective containers, as each algorithm supported by the STL expects a certain type of iterator. Next, we will move on to iterators. An iterator is a design pattern. But interestingly, the STL work started much before Gang of Four published their design patterns-related work to the software community. Iterators themselves are objects that allow traversing the containers to access, modify, and manipulate the data stored in the containers. Iterators do this so magically that we don't realize or need to know where and how the data is stored and retrieved. The STL broadly supports 5 types of iterators: input iterators, output iterators, Forde iterators, bidirectional iterators, random access iterators. The container implements the iterator to let us easily retrieve and manipulate the data without delving much into the technical details of a container. First, we will learn about input iterator. It is used to read from the pointed element. It supports pre- and post-increment operators. It does not support decrement operators. It supports dereferencing. Next, we will move on to output iterator. It is used to modify the pointed element. It supports pre- and post-increment operators. It does not support decrement operators. It supports dereferencing. The O-stream iterator, back inserter, front inserter iterators are examples of output iterators. Further, we will discuss about Forde iterator. It supports the input iterator and output iterator functionalities. It allows multi-pass navigation. It supports pre-increment and post-increment operators. It supports dereferencing. The Forde list container supports Forde iterators. Then we will look into bidirectional iterator. It is a Forde iterator that supports navigation in both directions. It allows multi-pass navigation. It supports pre-increment and post-increment operators. It supports pre-decrement and post-decrement operators. It supports dereferencing. The list, set, map, multiset, and multi-map containers support bidirectional iterators. Finally, we will learn about random access iterator. Elements can be accessed using an arbitrary offset position. It supports pre-increment and post-increment operators. It supports pre-decrement and post-decrement operators. It supports dereferencing. The array, vector, and dequeue containers support random access iterators. A container that supports random access will naturally support bidirectional and other types of iterators. In this video, we learned about the standard template library architecture.